Hey y'all, I'm going to be doing a recording as far as 9.3, or excuse me, not 9.3, section 9.8 goes. So this is going to be section 9.8. Now, 9.8 is all about higher order derivatives. Now the whole motivation is we can start with something like x cubed. Okay, can I find a derivative? Yeah, for sure, y prime. That's just 3x squared. Cool, not a problem. Can I derive this again? Absolutely, and in fact we get 6x. This is literally all 9.8 is adding. It's saying, hey, these derivatives that we land on that look something like this, turns out we can typically derive them more than once. Now how do we denote that? What we're going to do is we're just going to literally add another tick mark on. So if I see 2 tick marks, that means second derivative. Can I derive it one more time? Yeah, for sure. In fact, we'll just throw on another tick mark. Y triple prime. Derivative of 6x? 6. Can I go another time? Yeah, absolutely. Derivative of 6 is 0. I would throw on another tick mark, 1, 2, 3, 4. But that just gets kind of cumbersome. So ultimately what we're going to denote this as is a little parenthesis 4. That's literally what section 9.8 is about. It's just finding more. By the way, you could derive y infinitely more times. The derivative of 0 is just 0. So for instance, if I wanted to do another derivative, I'd do y parentheses fifth equals 0, the derivative is 0, 0, and so on and so forth. Now, you might see me write, instead of y, if my original function is f of x, I'll write it as f prime, f double prime, f triple prime, 1, 2, 3, and last but not least, f to the fourth and beyond, right? Because that's kind of how we're going to denote all this stuff. Now let's do some examples. First off, let's take f of x equals 3 times, no, sorry, going straight from the PowerPoint here if you want to follow along. F equals 3 times parentheses 2 minus x cubed cubed. Now if we derive this, well, first thing to note is, hey, we need a chain rule. We got something trapped by a power. Okay, let's go for it. Chain rule. When I derive this, what I'm going to get, well, first off, I copy down the 3, and then I do the chain rule. The derivative of the outside is 3 times parentheses 2 minus x cubed. Ooh, that's a horrible looking cubed. Cubed. Squared. So 3 times parentheses 2 minus x cubed squared. That's the derivative of the outside. And we're going to multiply that by the derivative of the inside, which will be negative 3x squared. So d out times d in. Now, since we're going to derive it a second time, I want to, in this case, I'd say find the second derivative of this function. What I want to do is simplify. So notice these big parentheses don't really matter since I'm just multiplying everything. So really we're looking at something like this. So we can start simplifying by multiplying our constants together. So for instance, I could write this as 9 times 2 minus x cubed squared times negative 3x squared. And in fact, I can go one more step and multiply these guys together to give me negative 27x squared times 2 minus x cubed. All of that squared. And boom, that's my first derivative. Now you could actually square out the second part of this. We could actually FOIL this out since we're going to be doing a second derivative. So if you wanted to avoid the product rule, that's what you would do. But in order to start deriving this, and let's go ahead and practice our skills from last section, we need to notice the following. What's our big picture rule? Well, it's something times something. That's product rule all day. So the product rule says, okay, well, let's do first negative 27x squared. All of that times d second. Well, the derivative of the second one, that's something trapped by a power here. That's chain rule. So derivative of the outside is 2 times 2 minus x cubed to the first, times it by the derivative of the inside. Derivative of 2 is 0. The derivative of negative x cubed will be minus 3x squared. So first, d second. Now we'll be adding on plus second, 2 minus x cubed squared, times d first. The derivative of first will be negative 54x. So we got first d second plus second d first. And it just so happened that d second required a chain rule. Now, if I said do not simplify, you could totally leave this here and that wouldn't be a problem. So what we're ultimately going to do, though, I just want to show us how we could simplify it. Sorry, that equal sign ended up looking horrible. If we wanted to simplify it, we'd be yet again looking for anything that multiplies. So notice that these parentheses don't really matter again. These are square brackets. So that really the things we can multiply would be maybe this 2, this minus 3x squared, and this minus 27x squared. Now if you multiply negative 27 by 2, you get negative 54. But then if you multiply negative 54 by negative 3, you get 162. If I multiply x squared by x squared, I get 162x to the fourth. So that's what I get by multiplying all those things in red together. And I'll be timesing it by 2 minus x cubed raised to the first power. So all those things in red end up giving me this. Now, you could, like I said, distribute this in as well. That'd be another way of simplifying it. But if we now look towards this guy right here, I'm just going to bring the negative 54x out front and write it as minus 54x times 2 minus x cubed squared. Now, last but not least, if you really wanted to, and what people tend to do is they tend to look for anything in common to factor out. You could say, hey, look, in each of these factors, in the first part and the second part, I have a 54 in common, I have an x in common, and in fact, I have a 2 minus x cubed in common. So I could, if I wanted to, write this as 54x times 2 minus x cubed, everything that was in common, times everything that's left over. Well, what's left over from this stuff? It'll end up being a 3x cubed. Right, the x cubed coming from this right here. Because I only pulled out 1 3, and the 3 coming from the 162. Now what was left from the second part over here? Well, it turns out that we pulled out the 54, we pulled out the x, so we only have one copy of 2 minus x cubed left over. Because I had 2 of them to begin with. You could even go one more step and distribute in that negative to notice that I'll get 4x cubed minus 2. So sometimes people like to go that far with their simplification. If I say, hey, simplify it, I'm really only going to expect you to go to this line right here, but just wanted to give you guys the full lowdown on it. Now I want to derive the function g of x equals 1 minus 4x all over x minus 3. And let's find our second derivative. Well, in order to get our second derivative, we have to go through our first derivative. So to get our first derivative, this is a quotient rule all day. We're going to do low times d high. Whoopsies. Low times d high, the derivative of the top is minus 4. So low d high minus high, 1 minus 4x, times d low. The derivative of x is 1, and the derivative of negative 3 is 0. So low d high minus high d low, all over the square of what's below. Now we need to look to do some algebra. In this case, we could distribute in this negative 4 and also distribute in this negative to that factor, because notice that multiplication by 1 doesn't really do anything. When I do this, and in fact I'll bring it down a little bit, but when I do this, I'll get minus 4x plus 12 minus 1 plus 4x all over x minus 3 squared. The reason I'm not squaring out the denominator is because the next step, notice these 4x's cancel. Therefore, the top of the fraction ends up just being 12 minus 1, or 11, all over x minus 3 squared. Now, by the way, we could, since we know we're going to be deriving this one more time, write this as 11 times x minus 3 to the negative 2 power, thereby negating the quotient rule and making this a chain rule. That's why I didn't square it out. Because now ultimately, hey, this right here, that's something we can derive. And in fact, we're going to. G double prime, that's chain rule all day, something trapped by a power. So I copy down the 11, and then I actually do the chain rule. So the derivative of the outside is negative 2x minus 3 to the negative 3 power, times the derivative of the inside. The derivative of x is 1, the derivative of negative 3 is 0. So we have d out times d in, and then we just look to simplify. Notice these square brackets yet again don't necessarily mean anything because I'm just doing a whole bunch of multiplying. So that ultimately, I'm just going to have 11 times negative 2, or negative 22, times x to the negative, or x minus 3 to the negative 3. Or if I really cared to, I could write this as negative 22 over x minus 3 cubed. And that would be my answer. Now I'll be doing more videos on this stuff, more example problems, so be on the lookout for that. But really this section is just finding your first derivative, which, hey, we've been doing, landing on a function and saying, hey, I can derive that one more time. Let's go ahead and do that. So the real challenge of this section will be just doing algebra on the first derivative. The reason we want to do algebra on the first derivative is, oh my goodness, it makes it way easier to do my second derivative. For instance, imagine doing something like this, trying to derive that. There's way too many parts, so try to simplify it down to something that's doable. And in fact, remember, we could have even simplified this down a lot more, right? We could have FOILed out the squared. But once you do the algebra, just derive it again, and then you're good to go. If they ask for a third derivative, take your second derivative and derive that one more time. If they ask for a fourth, take your third derivative, derive it again. So this section is going to be a little monotonous, but it's really just getting in the practice of doing more than one derivative.